All right, now welcome back to the class. Now, last time we were talking about fraction, just a starting of fraction. And you learn about how to draw them. Now, that's very important. So today we'll go on, and in about 1 hour, we are going to cover everything about fraction. Now, that is actually a lot of work. Now, some of the things you already know, but some of the things I'm sure you don't know. So let's have a look at it. The first thing that I want to look at is fraction and a division. Now, are you aware that fraction and division, they are actually the same thing?
Yeah.
Yeah. Now, all of you are aware of that?
Yes.
Yeah, that's good. Now, the thing is, you get a fraction when you break up something. So you have a whole and you break up into equal parts. You get fraction. Now, and you also notice that when you have improper fraction, you actually have something bigger than a whole.
Yeah.
And you have to break them up too. See? So now, let's have a look at the fact that division and fraction is the same. Now, let's have a look at that. So here, the first one we are going to look at is a half versus 0.5. All right. Now, if you look at that, well, you can draw, if that you're going to do, so that is a half. And place value, you know that 0.5 is basically 5 out of 10. Now 5 out of 10, you simplify, that become 1 out of 2. So we talk about the same thing here. All right, so what it is. Now the next one, let's have a look at a quarter versus 0.25. So basically 0.25 is 25 out of 100.
Right. Yeah.
Now, if you divide by 25 and you divide the bottom by 25 and you get 1 out of 4, same thing. So they exactly the same thing. Now, the next thing we look at improper fraction. So we got 8 out of 2. Now 8 out of 2, if you draw it, it becomes like this. This is 1 whole. And because you have 2 parts, so you split into 2 parts, so that's not enough, you need another whole. Right? And that, so split half, so only 4 parts, that's still not enough, so keep on drawing. Now you got 6 parts, and finally you've got 8 parts. So that's it. So 1, 2, 3, 4, 5, 6, 7, 8 parts. Now 8 parts, but you divide by 2. So you take half of it. You take half of it, the top half. So that half of it. So that work out to be what? So here we have 4. Is this right? Or something a bit strange here? Now 8 divided by 2, you get 4. Now that actually 4 whole. So there is something a bit strange here. Because we are supposed to be 4 whole. Oh, that's true. That's true. That's true. Look, you don't divide. That actually a mistake here. We don't have that bit. That's it. Now, so you have 8 parts. So you have 2, 4, 6, 8 parts. And divide by 2, you get 4 whole. So that is 4 whole there. Yeah, that's it. So 1 that's what it is. So that 1 whole, 2 whole, 3 whole, and 4 whole, and divide into 8 parts. So yeah, that's it. So that's what it is. So division and fraction is the same thing. Now this is so important because this helps you to do so many things. No kidding. It is so important. So let's have a look at the next one. All right, and that is why at year 6 and maybe you go to high school, people start to write the division using the fraction way. So for example, you probably already know about the relationship, the distance, time, and speed, right? You probably know that, right? So the speed equal to
Distance upon time.
Divide by the time.
Yeah.
Now the thing is, but in high school, they don't write like that anymore. So they will write S equal to D over
T.
T. So that's what they will write, because a fraction and a division is the same thing. And for that same reason, you have A, the area, equal to the width times with the height and divide by 2. You know, so that kind of thing. So that's how they write. Right, so an example. Now there is an example here, right? So we'll see how we're going to write that. So if we're going to change into fraction format, we'll write 3 times with 5, and we'll write that over 4 plus 6. So that's what it is. So that becomes 15 out of 10. Yeah. So that's how you would do it. All right. Now, all right. So that's the example. Now, let's have a look at the next bit. Now, why this is so important? Because you use it to simplify the difficult divisions. Now, what it is? So you use it. Now, the step is first, you convert the division into fraction. And step number 2, you simplify the fraction. And then step number 3, you can do the division. That makes life so much easier. All right, so let's have a look. Let's try. Now, the first one we are going to do is we are going to divide 512 by 64. Now, that would be difficult. Now, so we don't want to do it. So we say that equal to 512 over 64. Now, we're going to simplify it. You know, the easiest way to look at it is that, well, we'll divide by 2. So divide by 2. So we'll get 256. And that is over 32.
What about 8?
And then you divide again by 2. Divide by 2 again. So you get 128 over 16. And then, yeah, you can divide by 2 again. So divide both by 2 again. So we get 64 over 8. Now, that falls into the timetable, right? So 8 times 8, 64. Yes, so, you know, that is done. Now, this is so important because when you get into exam and things like that, you need to be quick, right? So that one is like that. Now, the next one is a little bit trickier. So now we are going to do, somebody raise a hand. No, don't worry about that. You know, we'll talk about things later. So now we have 12 and we want to divide by 0.25 now. Well, you can do the hard way, you know, you can actually try to divide it, or you can use fraction. All right, let's try fraction way. Last time we tried to divide, this time we don't. So we did 12, now we divide by 0.25. Now, in primary school, you don't write like that because the teachers, they don't teach this kind of thing. But by year 6, I think this is okay. You know, year 6 and the teacher will take it. So you write 12 over 0.25. Now, we need to bring it to something more reasonable. So we will time the bottom with, let's say 100, and we time the top with 100 as well. So now we're going to have 1,200, and we have over 25. Yeah. And then you simplify. Now you divide by 5. You divide both by 5. So let's see, what would we get? So 25 divided by 5, we get 5. And the other one is, I think, 2, 4, is it? 240, is it? Yes. Yeah, that's it. So 240. And then now you can divide by 5. That should be easier.
Go to 48.
Yeah. That is good enough. Now,
48.
now if you look at the last one, now the last one is a little bit tricky. Now here we have 5, and we want to divide by a quarter. So, and how is it that it become 5 times with 4 over 1? So you flip over. That is a little bit tricky. Now, is there anybody here you know how that happened? Or it's just something that people tell you that's how you do it?
That's how I do it.
Yeah, that's right. Let's try. All right. So we're going to do a tricky one. So do a 5. And now that is a fraction over a fraction. So that is called a complex fraction. So that's what it is. All right. Now the trick is we want to get rid of the 4 at the bottom. Yeah, that's tricky, isn't it? So now all we need to do, now I'm going to show you. All we need to do is we are going to try to get rid of the 4. So we will time top and bottom with 4. So equivalent fraction. All right. So here we have a 5 times with 4. Now, because a quarter times with 4 give you 1. Yeah. See, a quarter times 4. That gives you 1. Now, so that is going to be equal to 5 times with 4 over 1. That's what it is. Does that make sense?
Yep.
Yeah, you time a whole number with a fraction, you time with the top. Therefore, 5 times 4 over 1 is the same as 5 times with the fraction 4 over 1. So that's how you flip the thing over. Make sense, right?
Yes.
Yeah, makes sense.
Yes.
All right, clear thing. Now we move to the next thing. All right, now common multiples and common denominator. Now, the common denominator is something you already know.
Yeah.
Yeah. Now, a common multiple is a share multiple of 2 or more numbers. So here, 12 is a common multiple of 2, 3, and 6. Now, be careful. A number is a multiple of itself. So that's something. Yeah, multiple of itself. Right? So that is something you must remember. You must remember. It's a bit strange, and some people don't like it, but that's what it is. So 6 is also a common multiple of 2, 3, and 6. And it is called the lowest common multiple, and they call it the LCM. Yeah. And that is useful because when you try to find a denominator that share between many fractions, you want an LCM, make life easier. All right, now when you try to find an LCM, it's sort of, if the numbers are small, here I'll have an example. You have 3, 4, and 6. It's pretty easy. All you need to do is to write them down. So we got 3, 6, 9, and 12. And then for 4, you got 4, 8, 12, and 16. And for 6, you got 6 and 12. So you see number 12 is shared between them. So that's pretty easy. Now, all right. So the idea is that the best common denominator for a number of fractions is the LCM of the denominators. So that's what it is. All right, now find the common denominator for 3 fractions. So 2/3, 5 out of 6, and 3 out of 8. And then write the equivalent fraction for them. All right, so we got 3, 6, and 8. All right, we need to worry. So we got 3, we got
24.
6, and we have 8. So all right,
24.
so we'll see. So here you would say so you want to start with the double of it. So maybe 3, 6, and you have a 9, then you have a 12, and you have a 15.
Yes.
Yeah, something like that. And probably you need more. Then you have 18, and you have 21, and you have 24, something like that. And here you have 12, and you have 18, and then you got 24. So we got 24. So we'll just stop there for a moment. Now 8, you got 16, and then you got 24. Wow. So that make it easy. So 24, 24, 24. So now we have 24, 24, and we have 24. So 3 fractions. Now, so, all right, let's deal with the first fraction. The first fraction is 2/3. So 24, if you divide 3 into 24, you got 8. So 8 times. So 8 times 2 at the top. So that you got 16. And then 24 go, right, so 6 go into 24. The next fraction, 5 out of 6. 6 go to 24, you got 4 times. 4 times 6, 24. So times 4 with the top. So 5 times 4, we get 20. And then the next one, 24, you got 8 3 times. 8 go to 24, got 3 times. So 3 times 3, we get 9. So that's it. That's it. So you have 3 fractions, and you make the common denominator to be 24, which is the LCM of 3, 6, and 8. Now, you can use 48 if you want to, but you don't want to because it becomes too big. So that's what it is. All right, now let's go to the next one. All right. Now, how do you add and subtract fraction? Now, the funny thing is adding and subtracting fraction is harder than time and divide. You know, that's a bit funny, but it's all come down to the fact right here. Is it impossible? Why is it impossible to add or subtract fraction without the common denominator? Now, you are told about this already, but do you really know why? Now, just look at the picture that I've got there. So I got half here, and I got 1/3 there. Now, the truth is you can't add them because they are not of the same size. If you count on your finger, you know, you sort of count 1, 2, 3. The reason you count on your finger because you think that the finger all the same, you know, you count 1, 2, 3. But here, the half is larger than 1/3. Not the same kind of thing. So you can't really add them. Now, it go back to counting, right? We can only count the same object, the same unit, because when you add numbers, you actually repeat the counting. That's what it is. Where addition is repeated counting. So look at the illustration I have at the bottom. Now, at the bottom, I have 4 chicks. So you can count them. So you can count 1, 2, 3, 4, and then you write 4. That's perfectly okay. Now, the next figure, you have a duck, a chick, a duck, and a chick. Now, we have a problem. You can't count them because they are not the same kind of thing. So you say, for what? Now, some of you will sort of look at it and say, oh, well, yeah, we can count. We call it 4 birds. Yes, you can do them. You can call them 4 birds, but you have invented a new unit altogether. So you define a new unit called bird, and then you have to convert. So you convert chick into bird, and you convert duck into bird, and then you can do it. So this is not quite math. This is kind of science, you know. So that's what it is. So what I want you to remember is that you cannot add or subtract the things that are not the same kind of thing. You can't do that. All right, so we'll go to the next one. All right, now, how do you multiply a fraction with a whole number? Now, this one is really easy. Now, when you time, actually, what you do is you repeat the adding. So, for example, when you time 2 out of 3 with 3, all you do is you actually repeat the adding. So you get 3 of them, you add together. That's what it is. So here you have 2 over 3 plus 2 over 3 plus 2 over 3. So you got 3 times of the thing. So you end up with 6 over 3. So basically, this is a shortcut, really. Oh, sorry, that's the wrong way around. So here, that, oh, no. The right way is to reverse it. Yeah, that's it. So what you really do is a shortcut. You time with the top. So if you have a fraction, so I'm going to get a fraction. I got A over B. Well, any number, A over B. Now, if I want to time with C, all I need to do is I'm going to time with the top. So basically, that become A time with 6 over B. Yep, that's quite simple. Right? So there's nothing really fancy about that at all. Now, the next bit that I believe many of you already know because you have gone through the year 6 stuff. All right. So equivalent fraction and canceling down. Now, this is so useful. So this is something you already know. So if you have 12 out of 36, you can cancel down, and we have, you know, done that. So you get to there. Now, so the canceling down is something that all of you know already, right?
Yeah.
Yeah. I want you to confirm that.
Mm-hmm.
Now, but how does this really work? Yeah, I suppose it's sort of pretty simple. I mean, you can sort of, well, probably I don't really have to like take you through the thing, you know, like it's quite simple. Now, the next bit is a bit trickier. All right, now how do you divide a fraction by a whole number? Now look at the picture, it looks pretty simple. So here you have 4 out of 5. So we have the thing there. So all we need to do is we just, if we divide by 2, that's what we do. We split by 2. So for that reason, it looks pretty simple, right? Now, what it means is if this is possible, if possible, you divide the top. So if you can divide the top, it's simple. So you got 4 pieces, you divide by 2, you get 2 pieces. Very simple. It only becomes a bit tricky when you cannot divide the top. For example of this. All right, if you try to divide the top, you have a problem because the 3 divided by 2, you don't have a whole number. Yes, you can still do it in this case, but before I talk about that, I want to show you the normal way. So you can use what I call equivalent fraction. So you time top and the bottom with 2, right? Now, don't try to annotate. It's all right. So here you have 6 out of 5 times 2. So you get to that stage. Then now, right? Actually, I think I make a bit of a mistake there because that should be divided by 2 there. Yeah, I need to have that divided by 2 there. Yeah, that's it. Now, so if I divide by 2, now I can do it. So I can divide the top now. So I end up with 6 divided by 2 up the top, and I end up with 3 out of that. So it turned out to be that you time with the bottom. Yeah. So it worked out that 3 out of 5, if you divide by 2, it becomes 3 times 2. So we make equivalent fraction 5 times 2, and we divide by 2. So that equal to 6 divided by 2 over 5 times 2. So that equal to 3 out of 5 times 2. Now that equal to 3 out of 5 times with 1 out of 2. So it turned out to be that all you need to do is you time with the bottom. So that is a shortcut. So that's how it works. Now, does that make sense? Does that make sense to all of you?
Yep.
Time the bottom?
Yep.
Yeah. You time the bottom if you can't. Now, I show you another trick. You don't have to in this case. Now, so if you have 3 out of 5. Now you divide by 2. It's still okay to divide the top. So you got 3 divided by 2 over 5. That's still okay in this case. Now that equal to 1.5 over 5. Make sense? Now you can time both with 2. So you end up with 3 over 5 times 2. So the same thing. You end up with exactly the same thing. You got into a decimal number, then you time 2, you get back to number 3. So work out to be the same anyway. So that still can so you can do it. Now, the next thing is when you multiply a fraction by a fraction. And this is really easy. It doesn't mean that you really understand it, but all you need to do is to time the top with the top and the bottom with the bottom. Now, well, teacher probably won't tell you why, you know, they say, oh, that's what you do. So, all right, so 2 over 3, you time with 4 out of 5. Now you just top times top and bottom times bottom. So 3 times 5. Now that equal to 8 out of 15. Well, that's what they tell you to do. but they don't really try to explain why. And, you know, when you grow older, you can try to find out by yourself. But I think it is important that we have to be able to understand why we do that if we want to become really, really good. All right, now I'm going to show you why. Now, we have already done the first bit here. We multiply a fraction with a whole number. We time the number with the numerator at the top, right? And when we divide a fraction by a whole number, if we can, we divide the top. If we can't, we time with the bottom. So we already know that bit. Now, we use this thing to show why we do the multiplication. Yeah, that way. All right, so let's try. So let's try with the same example. All right, so 2. No, I need to switch back to the pen. All right, so I have 2 out of 3, and I need to time that with 4 out of 5. Now, the first thing is I use the first thing that we do, time fraction with a whole number. Now, it works the same when you time with anything. It doesn't have to be a whole number. So I'm going to do it. So that equal to, I'll make it a bit bigger. So I have 2 here, and I have 3 at the bottom. And I time that with 4
and then you time
out of 5. That's it. So I time with the top. So that's what I will do. So I time with the top. All right. Now that equal to 2 times 4 over 5. And then the whole lot is going to be divided by 3. Agree? Make sense? Now, the next step is I look at it. So now I rewrite it. I got 2 times with 4 over 5. Now divide by 3. So that's what it becomes. Yeah, that's what it becomes. So now, because it divides by whole number, I time with the bottom. So I have 2 times with 4 over 5 time with 3. Time with 3. The 3 times with the bottom. Yeah. So that's it. So that equal to 2 times 4. And I can swap the position. So equal to, that is 3 times 5. That's it. So I have proven that that's how you do it. So this is actually called a shortcut. That's actually a shortcut. The long way is what I have shown you. That's the long way to do it. So the shortcut is just to time top with the top and bottom with the bottom. You get it?
Yep.
Good. Get it? Yeah. All right. Now, next, we are going to go a bit further. Now, division of fraction. Now, again, how does it really work? Again, teacher generally don't tell you why. All they tell you is you flip the second one and then you time. And they come up with a fancy name. Here, the fancy name they come up with is the reciprocal.
Yes.
Now, that one is the one when you time with a fraction, that fraction turned out to be 1. You know, it's sort of, it doesn't make sense to a lot of people. So this is what they say. If you have 2, 3, the reciprocal of it is 3, 2. And all they say is that if you time the 2 together, it will be 2 times 3 and over 3 times 2 and the thing equal 1. And they say just, if you want to divide a fraction, you time it with the reciprocal of it. Now, that doesn't make sense to anybody at all. Now, what I'm going to do is I'm going to show you how it actually works. And if you're lucky enough, when you go to year 7, you know, some teacher might sort of show you, or you have to work the thing out yourself. All right, let's have a look. Now, but the first thing I like you to take a moment and have a look at fraction, right? Scan your eye a little bit through them. I'll get my glasses, make it easier for me. Now, the fraction doesn't have to be whole number. So you have, oh, well, actually, wrong way again. Now, yeah. So we have a decimal number as the numerator. Now we have a decimal number there as well. And here we have a sum. And here we have a product. And then the next one, we have a product as well. Right, so all these are fraction. Yep, a number sentence, and the the denominator is actually a fraction. So that is interesting. See, so all those, they are all valid. Now, so the numerator and the denominator can be anything at all. Can be anything, such as fraction or even a number sentence. All right, now, how are we going to use what we know so far to show that when we divide a fraction, we just flip the second one over and we time. All right, this will be interesting. Now, let's see whether I remember how to do it. All right. So sometime, you know, like if you haven't done this for a long time, maybe you don't remember. So let's try something. So here we have 2 out of 3. And we divide that thing by 4 out of 5. All right. Now, one thing we can do is we can set it up like this, a long one. So we have the 2 out of 3 there as a fraction of 4 out of 5. Now that is going to be interesting. All right, so now I just try to save a bit of space. So that's it. So now we convert a division into a fraction. Now the next step is, now we want to get rid of the annoying number 3 as denominator on top, and we also want to get rid of the number 5. So let's try. So first we try to get rid of the number 3 first. All right, so we'll see. So now we're going to time that thing with 3, and we're going to time the bottom with 3 too, and see what we get. So here we have 2/3 times 3, so we end up with only 2 and nothing. Yeah, only 2 there. And now down here we have 4 times with 3 over 5. There we are. So that's the first step. All right. Now we want to get rid of the annoying 5 at the bottom. So we're going to time both top and bottom with 5. So we time with 5. Hold that. There we are. So here we have 2 times 5. Now cancel down. So here we have the 5 and the 5 there, so they cancel down. So I'm going to change color into blue, so they cancel down. Now, you know that bit already in year 6. thing. Cancel that. So now what happened is you will have 4 times 3. Yeah. Now, so we're going to swap the order of that. So we are going to rewrite it. So we have 2 times with 5 over 3 times with 4. Now we can separate it. Now it becomes 2 out of 3 times with 5 over 4. Isn't that pretty? So that's it. So we have proven that what we do. The shortcut is to flip the second one and we time. Now, did you follow me? Yep, so one of you vote yes, so you follow me. Right, now the thing is, don't worry, the video is going to be posted into Google Class, so you can go over the whole thing again. So there's no problem with that. All right, so that is probably the most challenging bit. All right, so now we are going to go to the next one. Now this one is easy. Many of you must know. So the question is, what is a fraction of a number? All right, here an example is number 45. So we have what is 2/3 of 45? A fraction of a number, so we divide it into 3 parts.
And then we
So,
by 2.
So we divide into 3 parts. So we get 15 per part. So that's 15 and 15 and 15 and 2 parts. So we time with 2 and we get 30. What a beauty. All right. But the bit that you need to be careful here is that a lot of the time you need to be able to reverse the operation. To reverse it. You look at it. So now let's have a look at this bit here. Now, so when 4/5 of some number, right? Some number, something you don't know, is 36. What is that number? So you refer to it, you see 4 parts. 4 parts give you 36. So 1 part is 36 divided by 4. You get 9 and then you time it. So basically, you always take the number 36, right? And you divide by the top bit, the number of parts, and then you time with the bottom part. Yeah, so that's what you do. So the number in this case is 45. So now, that bit is important because sometimes you have to reverse an operation to be able to solve a math problem. Now, the next bit that I want to look at is called a number as a percentage of another number. Now, be careful. Now, I'm sure you already cover what a percentage is. It's just a fraction out of 100. So what is 2 as a percentage of 8? All right, let's try. So here we have 2 out of 8. Now we simplify to get to the next step, we get 1 out of 4. And then we need to get the bottom bit to become 100 because we want a percentage. Now we see that if we time 25 with 4, we get 100. So we time the top with 25.
Roger.
Yeah. So now we have 25 out of 100. So we write 25%. Yeah. So that's what you do.
No.
All right. Now the next bit, what is 2 as a fraction of 3? Well, Now, as a fraction is easy. So 2 as a fraction of 3, you just find, say 2 over
times 100.
3.
So basically,
Now, but
200 divided by 3.
if that is a percentage, now we have an issue. All right. So now we have 2 out of 3. Now, one way is to use the equivalent fraction. We time both top and bottom with 100. We get to the next step. We have 200 out of 300. And then we need the bottom to be 100. So we divide 300 by 3. So we have to divide 200 by 3 as well. So we end up with 66.66 over 100. So we call it 66.66%. Now, and that is why a lot of the time you end up with a decimal number. You won't get a whole number. Now, that looks complex. You can always do this. That seems to be easier. You just divide the two numbers. So you divide 3 into 2 and you get 0.6666. Right? And then you time with 100% and that's it. You get 66.66%. Now, do you know all this before or any of you don't? No? No feedback? All right. Now, does this look okay?
Yep.
Yeah. Now, anybody have problem with this at all and want me to go over the thing once again? No, that's okay. So, all right, now let's just patiently and slowly. All right, fraction and division is the same thing. So, you know, this is pretty simple. So a quarter, compare a quarter to 0.25. Now, I want you to try on the paper. So do the division, try to divide 1 by 4 as an algorithm. So you do a 1, right? No, wait. So 1, and you divide that by. All right, so basically here we have 1, you divide by 4. Now that looks pretty easy, right? Need a 0 come in at all. Change the 1 into 10 tenths. Right, so now we have 2. 2 times 4 is 8. And we subtract, we get 2. Now we change the 2 tenths to 20 hundredths. Right, and then we have a 5. Now 5 times 4 is 20. Right, so we end up with 0.25. So they are the same thing. All right. So division and fraction, the same. So here we have 25. We can compare out of 100 as a number. And we can simplify. So we can divide by 25, divide by 25, and we end up with 1/4. Now, what does that make sense, right? All right. Now, Chu. Now, I want you to have a go. I want you to have a go first, and then I'll go over it later.
2.5. Yeah, that's what I got.
Yeah. Yeah. Well, obviously, it is 2.5. Yeah. It obvious. So the thing is, the way it works is what you should have done is by diagram. So here we have, right? We have that.
That's what I
So
did.
that's one whole.
Yeah, I did.
And
Not.
the denominator is 2. So we split it. So we got 2 parts there. And then that's not enough. Only 2 parts. So no. So now we have 4 parts. 4 parts. That's still not enough. That's still not enough. We need another whole. And we split again. Now we got 6 parts. So now we need 5 parts. So we 1, 2, 3, 4, 5. This is how you show the work happen. So 1, 2, 3, 4, 5. Then you have 5 out of 2.
That's what I did.
So that's it. Now, then we are going to divide and see what happens. So we divide, right? So we divide 5 by 2. Divide 5 by 2. So here we have 2 parts. So 2 times 2 is 4. Subtract, we get 1. Now we need to change. So put a dot in. We need a 0 come in, and we got a 5. So 5 times 2 is 10. So subtract, we get 0. Now the 2.5 is actually 2 and 5 out of 10. It's a mixed number. And that becomes a 2 and 1 out of 2. Yep. Now, and then you can go further. You can convert that into improper fraction. Improper fraction, and that equal to 5 out of 2. So that's it. So you show that how they look exactly the same. All right. Now the next question is 2. With 2 and question number 3. How that one work?
It's 16 out of 10. 50.
Now, so work on the paper and see what happened.
16 out of 10.
Now, all right. Now, so the first one, we know that we want to division to fraction, right? So division to fraction. So first one, we got a division sign here. So we have 2 times with 3 plus 5 divided by 6 plus 4. Now, I don't want you to calculate really. All I want you to do is to write them as fraction. So here we have 2 times with 3 plus 5 over 6 plus 4. That should be good enough. You don't really have to calculate the thing. But the reason why I say you have to be careful about the BODMAS rule, because you have to know where the division is, so you can do the conversion. Now the next one is 2 times 5 divided by 2 times 3. Now this is really difficult. Now this one is tricky. Now any of you has done it?
I don't think it's a fraction if you'd like to apply the BODMAS rules.
Yeah. You have to be very, very careful here.
Because if you division first, so 5 divided by 2, that's equal to 2.5. And then you can do 2.5 times 2, 5, and then 5 times 2 is 15.
Yeah, you have to be very careful here. Now I'm going to show you. So the way it works is like this. The way it works is like this. You have to have the first thing needs to be done first in order. So you have to times 5. That needs to be done first. And then because it go from order from left to right. So what it means is that that whole lot, right, needs to be done first. And that divide by 2. So that what happened. So after that is done, then you have time 3. That's what it is. So when you write, it will become something like this. 2 times 5 over 2 times 3. And that will equal to 2 times with 5 times with 3 over 2. Now, do you have something similar to that?
Yep.
Yeah, it's tricky. It's not all that simple, that one. All right, now we'll go to the next. Everything will be on Google Class, so you don't have a problem. Here, try to do this division. So you got 875 divided by 125. So you try to do this. Then change it, no, right? So try it. So that, and then change it into a fraction, simplify, then do it. All right. So basically what you would do is 875 over 125. All right. Now, so that is that one way, and the other way I want you to try is to do 875 divided by 125. So I want you to do both of it. I want you to try both of it and feel which way is harder. Now, have you got the answer?
Yes.
It's 7.
Yeah, it's 7, isn't it? So the first way, you would divide by 5, divide that by 5. And you get 175. Now over 25, then you divide by 5 on both top and bottom again. And you get 35 out of 5. Then you get 7. So that's one way to do it. Now the second one is a bit tough, isn't it? It's 125. So make a guess. All right. So we'll get 125. Now wait, I'll do it away from that spot. So I have I make a guess 125. And I time with 6. See what I get. All right, so I get 750. Now that's not good. That's not good. So I say I try 125. I time with 7. Just a guess. And then I get a 75. That's it. So that is going to be a 7 here. And then I got a 75 and subtract, I get a 0. Yeah. So it's easier. It's easier to do
The fraction.
All right. Now you can write your own notes if you want to. All right, the next bit, let's have a look at it. write down your definition of a common multiple of two numbers. Now, the reason why I want you to practice this because I want you to be able to communicate. If you are in a classroom and you talk to other people, or maybe you try to explain something to a younger brother or sister, how are you going to explain? What is your definition of a common multiple of two or more numbers? All right, write it down and then we will check.
Done.
All right.
I'm done.
Now, everybody done?
Yes.
Now, any one of you want to volunteer to say what you write down? Yep, go on. Yeah.
Common multiple is a number that is common in two different timetables.
So that's one way. Yeah. Well, anyone else who want to say what you write down as a definition? Yeah. Now, all right. I'm going to give you my definition. All right. So I would say that a common multiple of two or more numbers is a larger number that all of these numbers can divide into. You know, sometimes you may say, oh yeah, that definition is not strictly, you know, true. Maybe when you have the largest number of the three, you know, is a multiple of the others. So, you know, sometimes you have that as well. All right, so an example is 2, 3, and 4. All right, so the common multiple, so the lowest common multiple in this case we have is 12. So in this case, my definition sounds right. This is a larger number that all the others one can divide into. But there's another case where it's not quite true. So if I have number 3 and number 6, right? So the LCM is actually 6. So it's not a larger number. In this case, 6 is actually a multiple of 3. So it's just a number that all of the other numbers can divide into. That's all what it is. Yeah. Now, the next bit here. So when you do the addition and subtraction of fraction, it's okay to use the product of the denominators. Now, it's very big, you know, sometimes it's very hard to find the LCM. And you say, oh, well, you know, I don't care. I just time all the denominators. Yes, that is something you can do. It's not the best, but that's something you can do now. But do you know this at all? You can just time them. So for example, for any number, if you have A over B and C over D, and you have A over F, right? So you have 3.
30.
So A over B. Now the common denominator, you can just say B times D times F. That's okay. It's not good, but that's something you can do. All right, the next bit is really simple. Find the lowest common multiple of 2, 3, and 5 and show it. So do that on your paper. 2, 3, and 5. Right. So here we have 2, 4, 6, 8, 10, and more, and you know, a bit more. And once you actually get to pretty far, you go to 30, that's a bit of a trouble. So 3, 6, 9, 12, 15, 18, and it's pretty far. You have to go all the way to 30. And then the 5, you have 5 and 10 and 15, 20 and 25 and 30. So all the way to 30. So eventually you get to 30 and you should get LCM of 30. That's what it should become. Now, there's something interesting here. You notice that 2, 3, and 5 are primes. Now, did you guys notice that the 2, 3, and 5 are prime numbers? Any of you notice that?
Yeah.
Yep.
Well, if they are prime numbers, they can't be divided by anything else. And when you have prime numbers, you know there's no need to do all that. If you have they all prime number, all you can do is you time them together.
Yeah.
And that equal to 30 straight away, save a lot of time. You get the idea? If they are prime number, nothing you can do. You just time them together straight away. And that is your LCM. All right. All right, so now write a fraction down. All right, so you have, so that 30, so that 30, so that you get a 15 over 30. So the first one. And then the next one will be 10 times. So that is 20 out of 30 for sure. The next one, now 5 go to that 6 times. So you got 18 out of 30. Now, so you can plus them together. So you should get 53 out of 30. Now, did you guys get that?
Yep.
Good, good. So that's what needs to be done. Okay. Now, so the next bit. So the sum, yep, so you can write the sum of the fraction down, right? Now, the next bit is rather interesting. It's not easy to find the LCM when the numbers are large. When they are small, you just run the list of multiples and then you pick. But when the LCM is very large, you know, like if the denominators are very large, for example, the denominator can be 72 and 126. What are you going to do? Well, are you going to run the list up, you know, to hundreds? You can't, right? And that is where you need to use prime factors. So you will need to do prime factors. Now, that's what you will need. Now, have you heard about that before any number, you can break into prime factors. All right, now, among the four of you, any of you know how to deal with this at all? To find the LCM for big numbers like 72 and 126. You know any way to do that at all?
I do.
You do? So one know about it? How
My
about?
mom taught me this really easy method. So
Yeah. Now, how you use the prime factor tree, right?
Yes.
Yeah. All right. Now I'm going to show you a way. I'm going to show you a way. Now let's find the prime factors. Right. This is the most efficient way. Now you can build a factor tree, but I don't like that one. It takes too long. So if you build a factor tree, you do something like this. You can do 72, and then you break it up into like 2. So so you can break it up into something like 36 and 2. So 2 times with 36 can give you that. And that is already a prime, so you don't worry. You break the second one.
I know the answer.
Yeah, so you do 18 or 2 and you know, stuff like that. But the thing is, the most efficient way is to do your mental math. So I'm going to show you. So 72, and you draw a line like that. And then you draw a prime factor. So you use 2 as a prime factor. So you divide in. So you got 36. Then you divide by 2 again. So you get 18. You divide by 2 again. And you get 9. Now you can't divide by 2 anymore. So you divide by 3, the next prime factor. So you get 3. Then you divide by 3 again, and you get 1. So that's it. So you have one list. So the first list is 2 times 2 times 2 times 3 times 3. So the product of all that will give you 72. Now, you have to do the next one now. So that is like 126. And you go through the same process. So here we have 2. So divide that by 2, we get 63. Now, you can't divide by 2, but you can divide by 3. Now, divide by 3, we get 21. Now, that's it. Now yes, we can divide by 3 again. And you have a 7. Now, you can't divide by 3. Now, you have to divide by 7. You get a 1. So now, you have 2 times with 3. And you time with 3. And you can time with 7. That's it. So that equal to 72 here. And that equal to 126. Now, we need to collect. Now, the interesting thing is you look at the 2 lists and you pay attention to the larger number first. So I better rewrite it. So you pay attention to this one first. That's the list. All right. So you now inspect the smaller list. So I'm going to write in blue. So the smaller list is 2 times 2 times 2 times 3 times 3. Now that equal to 72. Now, all right, we inspect, we keep the larger one. So we see a 2 in the larger one. So we will cross out one of the repeat 2 in the smaller one. And we see 2 of the 3 in the larger one, right? 2 of the 3. So we cross the repeat on the smaller one. We cross them out. So that's it. So now we don't have any more repeat. Now, so you put the thing together. So you rewrite the list for the larger one. So you rewrite it. So 2 times 3 times 3 times 7. Then whatever left of the smaller list, you will write it in. So I'll get the blue color. So I'm time it in. So I time with 2, time with 2. That's it. That's it. So whatever left. And now that give me the multiple. So I get 5, 0, 4. So that's what it is. Now, and one of you said that you have been able to work it out. Did you get the same thing?
Yeah, I think 504.
Now, how many of you actually get this done? Just one? Now, do you understand the process?
Yes.
Yes.
Yeah. Again, it's going to be put on a Google Class, so you don't have a problem. It's over there. You can watch the whole thing again. The whole idea is you focus on the larger number. You keep the whole thing. Then you look at the list of factors for the smaller number. Then anything you already see in the larger one, you will cross them out. That's all. And then you multiply all together. And you will get it. Now, if you check on many of the videos and books and things like that, you will find out that they do the factor tree, and I don't like that. It's too slow. The better way is just do a column and a divide. It's quicker that way. So that is a pretty good one. Now, all right. Now, let's move a little bit. Now we move more into theories, right? All right. So question 7. Why is it impossible to add or subtract fraction without a common denominator? Now, we talked about that before. I want you to write it down. You write what you think the right thing so you can communicate. You can talk to someone else about it.
You don't have the same unit.
Yeah, whatever. You write what your understanding there. Give you a moment to do that.
Darn. Just don't have the
All right. Anybody want to tell me what you write down? Yep. All right. Go ahead.
I wrote that they don't have the same unit.
Yeah. That's right. That sounds fair enough. Now look at what I write down. I write down without a common denominator, the parts are not equal, so you cannot add or subtract. The parts are not equal. All right, that's fair enough. That's all I want. Now, question number 8. Now here we have 3 fractions. I want you to work out and write it down on paper, so you're working out.
It's 60
60.
because we need to find. Yeah, it's 60.
Yep.
Yeah, that's why it's 60.
Because we need to find out because the only time 12 has a number which ends with 0 is when you times, like, the earliest time you have it, it's when you times it by 5.
Yeah.
And then 60 is like divisible by 50.
Now, so basically, you will find the LCM equal to 60.
Yeah.
And then you will end up with something like 18 over 60 plus with 24
Over
over
60.
60
And
plus with 45 over 60. And you end up with 87 over 60. Now, so you get that, right?
Yep.
All right. So you got 87 over 60. And you can simplify into 29 over 20 if you want to. That's what it is. All right, the next bit is we are going to do something very similar. This time we do a subtraction. Now, it's very easy. What do you get? So you add the first two and then you subtract. So that turned out to be 18 over 60. Now plus with 24 over 60. And
1
then
over 60.
subtract 45
1 over 60.
over 60. Now that equal what?
1 over 60.
no.
No, is it?
Isn't it 30? No, it's 33 over 60.
Yeah. So what do you get?
33 over 60. If you simplify it, then you can get 11 out of 20.
It's not 33 over 60.
3 out of 60.
It's 3. This is minus 3 out of 60. That's what it is.
Oh yeah, because it's 40
Yeah.
minus 45.
Yeah,
And that will equal to
yeah.
minus 1 out of 20. So the answer is minus
yeah.
1 out of 20.
Sorry.
Yeah, actually, I better fix that. I better write clearly. It's actually minus 1. Minus 1 out of 20. Yep. Now, is that all good?
Yep.
Good. Now, the next bit. Now, number 9. All right. Now, number 9 is how do you time a fraction with a whole number? I want you to write it down so you can communicate with other kids. All right, that's pretty simple. Now, any of you want to tell me what you write down?
Times the numerator with the number.
Yeah, that's all you do. You time the numerator with the number. That's all what it is.
Yep.
Yep. Now, then the next one we are going to calculate that, right? So that is going to be so simple. So that is going to be just time the numerator with number.
It's 4 out of 3.
Yep.
4 out of 3. That's all what it is. Now, the next bit. The next bit is a challenge. Now you show why. You show why. Any fraction A out of B times with C is the same as time the top A times C over B. Now this is a challenge. Now you can make it simple by using something like your number for your fraction. So it's okay for you to use something like 2, 3, time with 5 or something like that to show why it is. You don't have to use, A over B and, that kind of thing. That's too hard for you. It's okay for you to use a normal fraction, 2 out of 3 times 5 as an example and show why it works like that.
What I'm going to write is So basically, so C, it's like the whole number if you do that. So you're gonna time, so A, which is the numerator, and then if you like do C separately, C, it's the like whole number that you're gonna times it with. So basically, the numerator times the whole number.
Yeah. Well,
It's gonna
I'm,
be like out of the denominator. So
I actually think about something was simpler that you can show the young kids. So, I'll say, let's say do a tray.
like if A is 1 and then B is 4, and then we can say that C is 3. So 1 times 3 is 3, and then it's 3 out of 4. And then if you do like on the top, if you write A times C, which is 1 times 3 out of 4, you'll still get the same answer.
Yeah. Well, what I'm thinking is something so simple like this. So we have to do out of a tray, right? Now, yeah, well, actually, I'll pick a pick a better number because that looks so obvious. So let's say 2/5 times with 3. All right. So show young kid why you time with the top. So I would do something like this because 3 times, so that is 2 out of 5 plus with 2 out of 5 plus 2 out of 5 because the three times of it, 3 times of it. So that equal to 2 times with 3 over 5. Yeah, that's it. So that give me the idea that all I need to do is to do the time 3. That's it. Take 2 and time 3. Yeah. So if you want to show young kids, how it works, that is better. If you use A over B times C or that kind of thing, that is going to be a huge problem. It's just too hard. Can't do it really. All right. Now, the next bit is question 10. Do you know that the multiplication of fraction does not need common denominator? Now, I suppose by now everybody will just say yes, right? Right? By now. You don't need it. You just time it, right? All right. Now let's move on. Now question number 10. Now, all right. It continue actually. So let's have a look. So the general rule is we just time the top with the top and the bottom with the bottom. So it's simple like that.
Yeah.
All right. Now, so you do that bit and write it down. Right. So that is simple. So that's 2 times 3 times 4.
3, 4.
Over 3 times 4
It's 20,
times 5.
it's 20,
So you cross out, actually cancel down, cancel down, cancel down, cancel down.
it's 24 over 60, and if you simplify
Yeah.
it, it's 1 out of 5.
Yeah. So
It's
so 2 out of 5.
yeah.
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 Yeah. That's what it is. All right. Now question 11. Question 11 now. Do you know how multiplication of fraction really work? And write what you think about it. So basically, if some people ask you, how does it really work? Or if you don't want to do this one, that's okay. It's okay if you don't want to do that one, but the next bit is a bit of a challenge. So why do we time the top with the top and the bottom with the bottom. Now, the hint is, you know how when you time a fraction with a whole number, or any number really, you time the number with the top. So that is the way to prove it. So basically, I can show you once again slowly so you get the idea. So here you have A over B. And you time with any other fraction, C over D. Now what you can do, if you use the rule of time the top to get started, you time the top to get started. So basically you have A time with C over D. So you time the top and then the bottom stay the same. So just time the top, that's all what it is. And then that means you time the top again. So you have A time with C over D. And then the whole lot is going to be over B at a fraction. The next step is you want to destroy the D. You want to destroy the D. So you time that with D and you time the bottom with D as well. So that helps you to destroy the D. So cancel down, cross, cross. You cancel that one down. So you end up with A time with C over B time with D. That's it. That's the proof. Why? So again, it confirmed that when you time the top with the top and the bottom with the bottom, it's actually just a shortcut. Yeah, but that's what we do all the time. That's what it is. Now, all right. So the next question, number 12.
It's half.
Simplify to simplest form by repeating the division of both numerator and denominator by the same number. Yeah. So you divide by 2. All right. Yeah. So that's what you do.
It's half.
Yeah. It's half. It's half.
Because the bigger the numbers, the quicker it is. So I just divided both.
Yeah, you can divide top and bottom by 16 straight away if you want to. Right? So that's what it is. But if you divide by 2, that is fine. So the 16 over 32, and you just divide by 2, divide by 2. So you get A out of 16, and then you can have 4 out of A, and then just half. Yeah, you can do that. No problem. All right, now number 13, pretty easy. So you got A out of 15, and you time with 3, 4. So you can cancel down, right? Cancel down, you can divide that by 2, and divide that by 2,
5.
2, and you can have a 4. And then you can cancel down again. 2, and you got a 1 there. That's it. So that equal to 6 over 15. Is that right?
Yep.
Yep. That's 6 over 15.
5.
Okay, yep.
Wait.
Isn't it 2 out of 5?
Yeah.
Yeah, that's right. That's right. So that's 3 out of 5.
2.
Yeah, that's
2
it.
out of 5.
2 out of 5.
Oh, sorry. Is it?
Yeah, it's 2.
Oh, yeah.
Okay,
Right.
Because you're dividing by.
Yeah. Divide by 3. That's 2 out of 5. Yeah, that's it. That's 2 out of 5. All right. The next one is question 14. So we move that, we shift that a bit up. Now do canceling down to simplify this calculation and show your working out. Yeah, by now it's pretty simple. So that A out of 15. So time with 3 over 4 time with 1 out of 5. And obviously you flip the thing. You time with 5 over 2. All right, so cancel. 5, 5, we cancel. 4, we cancel with that. We get a 1 there. We got a 2 there. And then we cancel the 2 there with the 2 there, get a 1 there and a 1 there. That's it. Now, so we have 3 on the top. And everything canceled down the bottom, so we have 15. So that equal to 1 out of 5. Is that right?
Yep.
Yep. Yep.
All right.
Yes.
So that 14. Yeah. So, right. Is that right? No, it doesn't look right. I'm not sure. Is that right?
Is. What?
Now, did you guys get the same thing?
Yeah.
Yep.
Oh, well, good. Right. So if you guys get the same thing, because in one of my other sheet, it seemed that I got something else. Oh, well, anyway. Now, number 15. How do you divide a fraction by a whole number? All right. Now, write what you think. How do you divide a fraction by a whole number? All right. So what did you write out?
Divide the whole number by the numerator.
If possible.
What I wrote down was something else you can do. So
Right. You see, you divide the numerator by the whole number if that is possible. Otherwise, what do you do?
what I wrote, like this is something else I was told.
No. Well, what happened if possible? So you divide the numerator by the number. Now, if not, time it no time the number with the denominator. Yeah. So in this case, the next one, right? So when you calculate that, it's possible to do it, right? So you divide it. You got 3 out of
10.
Now, but if you can't do it, I give you an example. If you have something like this, 2 out of 5, you divide by 3. Now you have a problem. You cannot divide. Yeah. All right, go ahead. So what do we do? Time the bottom, right?
Yep.
Yeah, all
2.
right. So that become 2 and 5 times with 3. So that equal to 2 out of 15. So yeah. So if you can't do it, that's what you have to do. All right, so we are getting there. This is really good.
There's another thing that you can do.
Yeah, no.
You can like times it by half because go aggressive.
All right, so now. All right, let's move to the next, and the time is good too. We are nearly the end too. So, you know, the timing of the second lesson is quite good. It's actually get you to the end. All right, so question 16. Show the proof. Prove it. Prove that any fraction divided by a number is okay by dividing the top. Now, I make it simple so that we only need to show that rather than using, you know, the fancy kind of, you know, algebra kind of thing. So we'll just work on that. All right. So you guys do it on paper. It looks something like this, and you divide. Yeah.
Really? Okay.
So you can show the younger kids what to do. So the middle is there, right? It's there, right? So here we have 5 parts, and then we have similar to that. So we have 2, 10 parts. Yeah, that's it. Here we have 6, and that is 1, 2, 3, 5, 6. So that's 6 out of 10. 6 out of 10. So if we divide by 2, split it down there. So that's it. Yeah. Yeah, that's it. And now that become 3 out of 10. Yeah. Therefore, it means that you just chop it. Now, great. Now, question 17. Now, the general rule for division of fraction is to find the reciprocal fraction of the divisor fraction, then time the 2 together. So that's the rule. So that's the rule there. That's the rule. All right, so just do it without trying to prove it, of course. So we try to do it. This is all easy now. So 2 out of 3.
It's 2 out of 1.
Time with 4 out of 3.
Yeah.
Yeah, equal to
8 out of 9.
8 out of 9. And
Yeah.
that's it. So that one is pretty simple. Now the next one is easy. Now, 2 ways to do it. Yeah, 2 ways to do it. Now, so the normal way you would do is you do a 7 out of 10, and you time the bottom with 2. So you end up with 7
out of 20.
Out of 20. So that's the normal way you do it. The other way to do it is okay. High school, you do it a lot. So that's 10. So you can divide. So that's 3.5 out of 10. And then you time 2. and then you get 7 out of 20. So both of them are fine. Yeah, that looks pretty good. We are getting to the end. So now, now the next one, question 18. What do you do when the numerator is not divisible by the divisor? You know what you write down. You time the bottom, right? So you can write it down. You time the number with the denominator instead. And so here become a time and you do the bottom. Yeah, that's it. So that's 7 over 10 times with 3 equal to 7 over 30. Yeah. Now, by now, you probably know, but I like you to write what you think. So, do you know how division of fraction by fraction really works? Write what you think about it. And then the next bit is a challenge. Do you remember what I showed you, right? The proof of fraction division rule. So spend a bit of time, muck around a little bit, see whether you remember how the thing is done. Now, any one of you manage to do the second bit, show the proof of the fraction? Any of you manage to do that at all? Any of you manage? No, no, one, no. Yeah. Now, I'm going to slowly show you. I'm going to slowly show you. So here you have division of fraction. So you have A, B, that's the fraction. You divide by anything, a C, and a D. Yeah, C over D. Now, the first thing you have to remember is that you need to use the rule that division and fraction is the same thing. So you have A over B as a fraction out of C over D. So division and fraction is the same thing. So you set up like that. Now, you want to destroy the denominator of some of these, all right? So first, I look up the top, I see that A out of B, so I want to destroy B. So I'm going to time B to top and bottom. All right, so I'll try to do that. So I will end up with the chance to cancel out the B. So I cancel out the B, so cancel out the B. Right, now the next bit, is so I want to cancel out the B, so I'll end up with only A on top. And then here I have the bottom, I have C time with B, so I time the top. Yeah. Now I want to destroy the D. I really need to destroy the D. So I'm going to time both top and bottom with D. I want to destroy it, time with D. So I end up with A time with D at the top, and I destroy the D. So I destroy the D, cross out, cancel out, destroy the D. So I have a C time with a B. Now all I need to do is to swap the place. So that equal to A time with D over B time with C. Yeah, that's it. Now you break the thing up once more. So that become A over B time with D over C. There we are. Here we have C over D. And here we have changed it to D over C. So that is the proof. Now, this is my way of doing it. There is another way. In one of the videos that I post into week 2, if you watch, they actually show you the reciprocal and how that one is done. It's more complex, but you will see one of the things there. And it shows you how the thing is done. All right. So, clear that. That's it. So we reach the end. Now, we move on.